Hi guys, Dr. B here. So this is chapter 8, part 2 of genetics. We're going to look at pedigrees as well as inheritance. Not like money, but another type of inheritance. So what is a pedigree? A pedigree is a way to depict a family history, and it shows how a trait can be inherited over generations. On the right side, you see an example of a pedigree, and we'll get into more detail, like what it means, etc., in a few slides. Another important definition is the term carrier. So a carrier is somebody who is heterozygous for a given trait. That means they have both a dominant and a recessive allele, or recessive copy, dominant copy of the same one, of the same trait. And even though they have they have like the allele for it, you still do not show symptoms. The problem is that a carrier can pass on the gene to the next, pass on the trait to the next generation. So looking at a pedigree, horizontal lines indicate matings like this. These are matings. Vertical lines indicate offspring. So we're talking about like here to here. Those are the vertical lines. Square indicates male, circle indicates female. A colored shape represents affected individuals, and we don't see this right now, but two parallel horizontal lines indicate something called consanguinity, and we'll talk about that later on. So if a disorder or if a genetic disorder is considered autosomal, that term, it means it appears in both sexes equally. If something is sex-linked, means it usually is only seen in males. Sex-linked disorders are carried on the X chromosome, so a male who carries the recessive allele on the X chromosome, they will probably exhibit the condition. Well, they will exhibit the condition, most likely. A female who carries a recessive allele on one X chromosome, she will not exhibit the condition if she has a dominant allele. However, if she has two recessive alleles, then she will express the condition, whatever it may be. So how do you know if it's dominant or recessive? So if the gene is autosomal dominant, every individual will have a parent with the condition. If it's recessive, an individual with the condition can have one, two, or neither parent exhibit the condition. So if something is dominant, means that it's probably going to be seen more frequently throughout the pedigree. If it's recessive, probably not. Heterozygous or homozygous. If a person is homozygous dominant or heterozygous, their phenotype will show the dominant allele, whatever it is. Remember that phenotype is physical appearance. If person is homozygous recessive, their phenotype will show the recessive allele. If they are a heterozygous carrier, they can produce children with that mutation potentially. So here is a pedigree example, and this one shows two families. So you have the grandparents, and then they have their own offspring. And so these two mate, there's these two mate, and they have their own offspring. The darkened ones, again, darkened symbols indicate people who are affected by some trait. The rest, the ones that are not colored, indicates that they're not affected. So autosomal dominant, if you look, it appears in every single line. So let's say this is parents or grandparents, then it appears here. It appears in this generation and in this generation. So notice how this mother has it, then the son and the daughter have it, and then this father passes it on to their daughter. So it appears in every single generation. So X-linked recessive, yes, it pops in every generation, but look at how it's being passed on. So this mom has it. This mom for sure has the disorder. And notice how she passes it on to the males. this female and this male, they mate and they have offspring that all have the disorder. But notice how this mom, this female right here, does not have, she's not really showing the trait, but look at how one of her sons is actually affected by it. So this woman is a carrier. So common X-linked disorders, deuteranopia, are red-green color blindness, hemophilia. Basically, if people get cut, they tend to bleed a lot profusely. Male pattern baldness and albinism, so albinos is what this is referring to. Albinos. So this is called the Ishihara test, and I kind of want to do this in class. So we'll just watch this for now, and then we'll be good. So if you can see all 6 numbers that are shown here, you don't have a red-green color blindness. So I kind of want to find out in class, so don't spoil it. I want to ask in class. So then the next slide I'm going to show you, it's going to show you what it looks like if you are potentially colorblind. So on the left side, if you have regular vision, you'll see all the numbers. However, if somebody is red-green colorblind, they can only see 2 numbers. That's what they see. So consanguinity, whatever that means. So consanguinity, remember I said it's indicated by 2 horizontal lines. So you'll notice that these 2 parents, I'll mark them in green, notice where they're kind of related first. So notice you have the grandparents, then they have these parents, and then anyway, moving on. So consanguinity. In dogs, unfortunately, this occurs because dogs tend to be bred, they're called purebred. So they want to make sure that they have the best genes. They just kind of mate with the same, etc. in breeding. And unfortunately, Dalmatians, they tend to end up deaf, and German Shepherds end up with hip dysplasia, where the hip joint doesn't really fit into the pelvis like it's supposed to. In humans, Queen Victoria, she was only 18 when she succeeded the throne, and she married Prince Albert. They were actually first cousins. And the thing is that Queen Victoria was actually a carrier of sex-linked hemophilia. So for example, this is actually the pedigree of Queen Victoria and Prince Albert. So they had 9 children, and if you notice that this female carrier, she passes it on. So she's a female carrier. She passes it on here. There's a male hemophiliac. He dies young, probably because he bled to death. Then Beatrice is a female carrier. So notice how she passes it on to here and here, but the daughter, I think it's Victoria, marries somebody, and notice how her being a carrier for hemophilia passes it on to 2 sons, and they both die relatively young. Same thing with these children, or these husband and wives. And notice again right here, this should actually be double line like that, and also right here as well, because if you notice, they're cousins. That they're cousins. So yeah, a lot of inbreeding and all that causes these genes to just reappear more frequently. So why would you use a pedigree? Well, sometimes it's a tool to help learn about how a trait is passed on or present or not present in one's family. Who would prepare one or make one? Somebody called a genetic counselor or a geneticist would do so.